Okay, so here we will be taking irrational numbers. Okay, irrational number, any number which is inside the root and you are not able to take it out from the root sign, it is not a perfect square number. For example, root 2, root 3, root 5, root 7, and all those number which is not perfect square. And if you will try taking it out from the root sign, it is not possible. But yeah, long division method you have learned in the previous class, and you will try finding the value for root 2, okay, by using long division method for finding the square root. Have you learned long division method for finding the square root of any number? Yes, students, Aleph, Afia, Apurva, Khadija. Can you see the screen?
Yes, ma'am.
Yes, ma'am.
Okay, so long division method you have learned in the previous class, right?
Yes, ma'am.
Okay, don't worry. I'm not going to tell you to find the value of root 2 in decimal. No. Okay, I'm just telling you by long division method, if we will try finding the value of root 2 or maybe root 3 or maybe root 5 or maybe root 7, we will get such a decimal number, okay, which will just keep on going and keep on going and keep on going and keep on going and never ever stop. And if you will check, you won't be getting any proper pattern. For example, root 2 value will look like 1.41423576. Actually, it is not the value. Randomly, I am writing, for example, 753214138762. Anything, any number, any digit can keep on coming and keep on coming and keep on coming. You won't be able to find any proper pattern over here. And these type of numbers are irrational number. Okay, so in root 2, root 3, root 5, root 7, then root 6, okay, then root 8 also, then not root 9, root 10. These are the number which will give you such value, such decimal number when you will use long division method. Okay, so these are irrational number. Today we are going to discuss how to locate these numbers on number line. That means, are we going to discuss geometry portion? Yes. Okay, how to represent root 2 on number line. So this, the line which you use for representing the integers, okay, 1, then 2, then 3, then -1, then -2, -3. This is not just containing integers. Okay, this line contains rational number which you have learned in the previous class, and today I am telling you the same line contain irrational numbers as well. Okay, so actually this is number line which is real number line. We keep on calling it number line, number line, number line, but actually it is real number line. In future, in class 11, we will start calling it real line. Getting it? Okay, so let's see how to represent root 2 on this number line. Okay, or real number line. So we are going to discuss how to represent root 2. Okay, as you understand root 2, we don't know the exact value. Okay, calculator or whatever will not be able to give us exact value. Yeah, approximate value we will be getting with the help of calculator, but we don't need approximate, we need exact, and we are not able to find the exact value, but still we want to locate it. So we will use a trick, to locate it. Okay, and the trick is to use the Pythagoras theorem. Everyone over here, do you know what is Pythagoras theorem?
Yes.
Afia, you know what is Pythagoras theorem? Aleph, Pythagoras theorem, you know, right? Right, Aleph? Apurva, do you know Pythagoras theorem?
Yes, ma'am.
Khadija, do you know what is Pythagoras theorem?
Yes, ma'am.
Okay. So yeah, okay, let's use Pythagoras theorem. Khadija, do you also know how to represent it on number line?
Yes, ma'am, I do.
Okay. No worries. Let's just finish it. Okay, these portions from here. Then we will be taking the next part, which maybe you will be learning for the first time. So root 2, we are going to locate on the number line. Okay, let's see how we'll be using Pythagoras theorem. So we will use a right angle triangle. Okay, Pythagoras theorem says that in a right angle triangle, opposite to 90 degree, whatever side is there, that side name is hypotenuse. So according to Pythagoras theorem, AC square is equals to AB square plus BC square. That means hypotenuse square is equals to perpendicular square plus base square. You can also just, okay, you can write it BC square plus AB square, and it's the same thing. Base square plus perpendicular square, or perpendicular square plus base square. But hypotenuse will be sitting on the one side of equals to. Hypotenuse will be sitting on one side of equal to. Okay, this is really important in Pythagoras theorem, that we must keep hypotenuse on one side and the other two side on the other side. Okay, so this is Pythagoras theorem. Now we are thinking that if we will take a triangle, okay, and we will take the height as a 1 unit, 1 centimeter, and the base as a 1 centimeter. Let's calculate the hypotenuse. Okay, let's calculate the hypotenuse by using Pythagoras theorem. So AC square, see, this is the formula, and here we are working. Okay, we are going to use the formula. So this formula says that square is equals to AB square plus BC square, and I am telling you, please take AB as a 1 and BC as a 1. Okay, and now tell me what is AC. So you are taking AB as a 1 and BC as a 1 because I have given you. From where it came, you don't have to worry about that. I have given you. Okay, so you are getting 1 plus 1. That means you are getting 2. Your AC square is 2. Then your AC will be square root of 2. Is it clear to everyone?
Yes, ma'am.
Yes,
Yes, ma'am.
Apurva, Aleph, are you getting it?
Yes, ma'am.
Okay, so
Yes, ma'am.
we realize that even though we don't know the actual value of root 2, actually what is root 2, we don't know. But by using Pythagoras theorem, if we will take the height as a 1 unit, 1 centimeter, and the base as a 1 unit, automatically this hypotenuse will come out as a root 2 centimeter. Okay, we are just taking the height as a 1 centimeter and the base as a 1 centimeter. Taking 1 centimeter as a height and base is possible for us. We are having a scale, okay, which will help us taking 1 centimeter. So 1 centimeter we are taking the base and 1 centimeter we are taking the height. Automatically the hypotenuse came out as a root 2. We will use this concept over here. Okay, so what we are going to do, we will draw a number line. That means a real line. We will draw 0 over here. Okay, 0. You can name it point O. And then since we want to make a right angle triangle by maintaining the base as a 1 and the height as a 1 unit. So here in this number line, we will be drawing a right angle triangle now. How? We will be maintaining the base as a 1. Okay, suppose this, let me show. Suppose this is 1, this is 2, this is 3. Okay, so you are taking the base as a 1. From 0 to 1, you are taking the base as a 1, which we have realized already. Okay, this 0 you are naming it a point O, and this 1 you are naming it a point A. Like whoever is having pen, paper, pencil, scale, please do it. Please do it. Apurva, you just came all of a sudden, so maybe if you can arrange, please. If you can't, then fine. Khadija, you understand this concept, right?
Yes, ma'am.
Okay, so if you can arrange, it will be better that you, one more time you will be able to practice. And if you can't arrange for now, all of a sudden, then just it's fine. Okay, leave it. So first we will be drawing a number line. In number line, we will be locating 0, 1. At least 0 and 1 we will be locating. 2 and 3 is not required for now. Okay, that means from 0 to 1 centimeter you will be taking. Now you want to make a height of 1 centimeter. Okay, so at a point A you will be dropping a perpendicular. Now let me remind you how you were making 90-degree previously with the help of compass. So previously you used to draw 90-degree on the straight line, the given line segment AB. How? You used to press the needle of the compass at a point A, and you can take any random measurement, anything. Okay, and you used to make an arc like this. An arc like this, right? I'm just showing you how to draw 90-degree. Why? Because we want to make a perpendicular line in our actual figure. That's why I'm reminding you how to draw 90-degree. Getting it?
Yes, ma'am.
Okay. So first, a line segment. This is random example. Okay. Don't relate it with the actual figure and all. Here I will show you how to draw 90-degree, and there actually we will be drawing 90-degree. Okay. So first I have taken a random line segment AB. On this line segment, we will press the needle of the compass at a point A, and randomly we will make an arc. Now without disturbing the measurement in our compass, I will now put the needle of the compass at a point P and will make an arc like this. Okay. Please do it. Yes, who is doing along with me? Please tell me. Afia, are you doing it?
Ma'am.
Yes.
My school teacher did it differently. First, she made the arc and then she made the semicircle.
Okay, it's fine. Okay, for making 90-degree. For making 90-degree.
No, ma'am. Like if you wanted to represent root 2, then she took the measurement as 2 centimeter, and then she increased it by 1 centimeter, and then like she made an arc and then a semicircle.
Okay, so you have used another method. No worries. You can follow the same. Okay. So basically, we do this method for this one, and for square root of decimal number, we use that method. But that can be used for any number. I'll be showing you both the ways. Okay. So let's cover this way, and you can completely keep it aside for now. Okay.
Yes, ma'am.
Yeah. Yes. Who is drawing with me? Aleph, Afia, Apurva, are you doing it with me?
Same with other
Ma'am,
names.
I also learned the other method.
Okay. Apurva, you also learn the other method?
Yeah.
Apurva, you learn the other method. Khadija, you learn the other method. What about you, Afia and Aleph?
Mom, we also learned the other method.
Okay, and Aleph, you also? Okay, let's do the other method first then. Okay, that method is helpful for drawing any irrational number. Okay, whether the number is just root 2, or maybe the number is okay 9.3, or maybe the number is 3.5, or maybe the number is root 5. Okay, let's do it. So first, what we'll do, first we will, since we want to make root 2 on number line, first we will draw a line segment of 2 centimeter. Just tell me that this method only you are talking about or not.
Yes,
This
ma'am.
number 2, you will be first making a line segment of 2 centimeter. Okay. Who is doing with me? Please tell me. Otherwise, I will just take a pause and will just proceed. Anyone who is doing with me? No one is doing, right? So let me explain it. First, you will be drawing a line segment AB of 2 centimeter. Then you will stretch from B 1 centimeter till C. Okay. Now you want to find the midpoint of AC. Okay. You want to find the midpoint of AC now. So what you can do for finding midpoint of any line segment, there is a rule which you have learned previously maybe. Okay. You can press the needle at one end point and you can take the arc little bit more than half. Okay, just okay, any random measurement you can take, it can be little bit more than half. Okay, so I'm just taking randomly like this. Now I will keep the needle at a point A and will make an arc on the upper side and a arc on the lower side. Now I need to press the needle at a point C since we want the midpoint of AC. So one time I will just press the needle at A. Another time I will press the needle at C. Okay. And we will cut the previous arc like this. Once you will join this two, you will end up getting the midpoint of AC. This method only you have used.
Yes, ma'am.
Okay. So once you will join this two, you will end up getting the midpoint of AC. Okay, midpoint of AC. Now what we want to do, we will be drawing a semicircle by taking the center as a O and radius as a AO. You need to press the needle at a point O and you need to take the radius as AO or maybe OC. Okay, AO and OC are same because you only divided it into equal part. Okay, so AO or AC, OC you are taking as a radius and center you are taking as a O and you are drawing a semicircle like this. If so far everything is clear, then let me tell you the last part. Now you will be dropping a perpendicular at a point B by using that method only which I was showing you, how to make 90-degree. Okay, you will make a 90-degree at a point B and you can name it MB or whatever. This BM will be square root of 2, right? Right?
Yes.
Okay, you can take this BM in your compass and now you can locate it on number line. Okay, you don't know what is exactly the value of root 2, but you understand this much is root 2. This much accurately is root 2. Now you are able to say. Okay, so this technique, forget about that technique. This technique is helping you finding root 2. Okay, or locating root 2 on number line. You can take BM and you can just locate it on number line from 0. Okay, 1, 2, this way. Number line you are having, there only you can just press the needle at O and you can mark how much is root 2. Is it clear to all of you?
Yes, ma'am.
Okay, so most of you already know this method. Who doesn't know? Aleph, are you there?
Yes, ma'am.
Are you getting it?
Yes, ma'am.
Have you learned same method?
Yes, ma'am.
Okay, so if you are not getting, please let me know. Okay, I'll be explaining it again in detail, but that time you have to have pen, paper, pencil, scale, everything in front of you. Okay, so how to locate root 2, how to locate root 3, how to locate root 5, how to locate root 9.3, how to locate root 3.5, all are having same process and this is the process. Okay, let's move. Now we will be discussing how to rationalize. How to rationalize when we are having, just a second. Suppose we are having, just a moment, let me check in book what is the next part. So today let's discuss how to rationalize. Okay. So rationalization means, suppose you are having 1 by root 2 and the statement says that you need to do the rationalization. Okay. How you will rationalize it? So let me clear it. Rationalization means removing roots from the denominator. Removing this root sign from the denominator, that's called rationalization. For removing this root, you can do whatever is possible, whatever works. Okay, any formula, any trick, any logic, okay, whatever, but just we want to remove the root from the denominator. While removing the root from the denominator, if we will end up getting numerator, okay, as a square root, okay, any term which is having a square root in the numerator, that is fine. Okay, let me tell you, in our overall, like throughout the world, in IGCSE, in IB, in all the curriculum, in all curriculum, in UK, in US, whatever, we don't keep the number like this. Okay, they don't leave the square root number in the denominator. Okay, they, if numerator is having a square root, that is okay, but if denominator is having a square root, they try just removing the root from the denominator. That is the general way of writing the number, general way. So if we are having a fraction, suppose we are having a fraction 2 by 5, and if we are multiplying same number in numerator and the same number in denominator, you understand that we are not changing the fraction, right? This two are equivalent fraction, right?
Yes, ma'am.
Similarly, once we will rationalize this 1 by root 2, we are going to get just another version, but our fraction will remain same. Okay, our fraction will remain same. Our purpose is to remove the root from the denominator, because that is the standard form, or most of the time it will also help us doing the calculation also. Okay, so for now let's focus on how to remove the root from the denominator. When you can see 1 by root 2 in the just this root 2 in the denominator, what you can do, you can multiply square root of 2 in numerator and square root of 2 in the denominator. Once we are multiplying same number in numerator and denominator, we are not doing any changes, we are not disturbing our fraction. Okay, it is completely acceptable, it is completely allowed with fraction. Okay, now we will be multiplying numerator with numerator, we are getting 1 into root 2, and we will multiply denominator with denominator. Once you will multiply numerator with numerator, you will end up getting root 2 in the numerator. And just now I told you, numerator is any square root term, that is completely okay, but not denominator. Okay, so your denominator is root 2 into root 2. Now whenever 2 is square root number, we multiply. Okay, they just collaborate together and they come inside one root sign. This just happen in case of multiplication and division, and due to this reason, this is creating a pair, and hence our final answer is just 2. Are you getting it?
Yes, ma'am.
Everyone, Aleph, Purva, Khadija, are you getting it?
Yes, ma'am.
Okay, so root 2 into root 2 is just 2. Why just 2? Because number collaborated together, multiplied together inside the one root sign and became just 2. So we are having just 2. And this is our answer. Again, I'm telling you, your purpose has to be clear. You wanted to remove root sign from the denominator. Okay, and you are done. In numerator, square root term is there. That is fine. but not in denominator, and that's called rationalization. Okay, so from now onward, whenever we will be having 1 by root 3, 5 by root 3, okay, 5 by root 7. So what we can do, we want to remove the root from the denominator. For that, we can
So
create a pair in the denominator. Yeah. Yes. Anyone saying anything?
multiply root 7.
5 by root 7. Yeah, yes, Afia, you said the answer.
Yes, ma'am. I was saying we should multiply the fraction into root 7.
Yeah, we should multiply root 7 and root 7. Why? So that the denominator will have a pair. Okay, so we will multiply root 7 into root 7, and one more time I am telling you, it is completely acceptable and allowed. Okay, with fraction we can multiply same number in numerator and denominator, we can divide same number in numerator and denominator. So due to this reason we are getting 5 root 7 in the numerator and just 7 in the denominator. Our purpose was clear to us. We wanted to remove the root from the denominator and we are done. So these type of example, if clear to you, then we can move to the next part. Let's see the next part. LF, are you getting it? Are you getting it, LF? Are you
Yes,
there?
ma'am.
Are you getting it? Can you do LF? Suppose we are having 5 by root 8. Can you tell me what will be the answer quickly?
5 root 8 by 8.
Yeah, 5 root 8 by 8. Okay, let's see the next type of question. The next type will be 1 by root 5 minus, let's say, just a moment. 1 by, suppose, 7 minus root 5. Okay, this is the next type. Here also our motto, our purpose is to remove the root from the denominator. Okay, and let's remove the root from the denominator. For removing the root from the denominator, here we don't know what to multiply because we are having 7 minus root 5 in the denominator. So here we can see it looks like x minus 5, right? Right? Whenever we are having x minus y or x plus y, that type of structure in the denominator, we will be doing the multiplication with the reverse. Okay, if x minus y is there, then you will be multiplying with x plus y in numerator and denominator. If you are not understanding that why we are doing it, please take a pause. Okay, just wait, I'm showing you why we are doing it. So we will be having 7 minus root 5 was there in the denominator, and we did the multiplication with 7 plus root 5 by 7 plus root 5. Due to that, now our numerator multiplied with numerator and denominator multiplied with denominator. Can you see a formula, an identity over here, x plus y, x minus y? Can you see a formula over here? Have you seen this formula that in one bracket x plus y, in another bracket x minus y, that is equals to x square minus y square,
Yes, ma'am.
right? Okay, due to this reason, we want to use this formula. And that's why whenever x minus y we will see, quickly we will multiply with x plus y in numerator and denominator. Okay, due to that our denominator will become x square, that means 7 square minus root 5 square. But the numerator is containing a square root now. That is completely okay. That is completely allowed and that is completely okay. Okay. So we ended up getting 7 plus root 5 by 7 square means 49, and root 5 square, just now we realize the root 2 square is just 2, root 3 square is just 3, root 5 square is just 5. Okay, so we are having 7 plus root 5 over 49 minus 5 will be 44. Any doubt? And let me tell you, the original question 1 by 7 minus root 5 and this step is exactly same. That means it looks different, but these two fraction are equivalent fraction because we just have multiplied the same term in numerator and denominator. Are you getting it?
Yes, ma'am.
Okay, is it
Yes, ma'am.
crystal clear to all of you?
Yes, ma'am.
So from now onward, whenever we will see x plus y structure or x minus y structure in denominator, we will be doing the multiplication with the opposite one just to create the formula. For example, if we are having root 5 plus root 2 by root 5 minus root 2, and again we have to do rationalization. So what we will do, we will be just focusing on the denominator, just denominator, because here only root is not allowed.
Multiply root 5 plus root 2.
Exactly. Okay, in numerator we are having root 5 plus root 2, fine. Okay, whatever is there in the denominator, fine. We will be doing the multiplication with root 5 plus root 2 by the same root 5 plus root 2 because our denominator looked like x minus y. So we have just done the multiplication with x plus y without even checking what is there in the numerator. That is not our concern. Making sense?
Yes, ma'am.
Now we will multiply. In after doing the multiplication by mistake, don't start canceling like this. Okay, we have done the arrangement. Now we need to multiply numerator with numerator and denominator with denominator. Let's do the multiplication. So the numerator, can you see same term? Okay, root 5 plus root 2 and root 5 plus root 2. You can write root 5 plus root 2 whole square. And the denominator, okay, x plus y, x minus y. So x complete square minus y square. The denominator is already sorted. We are having 5 minus 2. That means we are having 3 in the denominator. But numerator we have to find carefully. Okay, so let's find it. Root 5 square will be, okay, can you recall this formula? X plus y whole square. Formula is x square plus 2xy plus y square.
Yes, ma'am.
Yes, Khadija, all these things are known to you. Khadija? Okay, she's not there. Okay, let's continue. Just a moment, ma'am. Let's see the next one. Root 5 plus root 2 square. Okay, so this formula, you know, we'll be using the same formula over here. Okay, that means what we are going to do, root 5 plus root 2 complete square is root 5 complete square plus 2 into root 5 into root 2 plus root 2 complete square. Are you getting it, Aleph and Afia?
Yes.
Aleph, are you getting it?
Yes, ma'am.
Okay, so we will be getting just 5. We will be getting 2 root 10. Okay, you can again take both the number inside one root and you will be getting just root 10. And root 2 square will be only 2. 5 plus 2 is 7 plus 2 root 10. So we'll be having 7 plus 2 root 10. Actually, all these steps you need to show over here. But since we are having less space over here, that's why I'm showing you that we need to expand like this, and this is the final answer. Is it clear?
Yes, ma'am.
Okay. So this is how we are doing the rationalization. Always we are just keeping our eye on the denominator. Now you may get this type of question that simplify. You may get this type of question. Okay, now you understand while doing the rationalization, we are just getting the equivalent fraction. Okay, our final answer and the original question looks different, but actually these two are equivalent fraction only. So if we understand that, we will do rationalization of this one. We will do rationalization of this one, and then we will be adding this two. Let's do it. Okay, so let's do the rationalization of this, the first term, that is 1 by root 6 plus root 5. We need to do the multiplication with root 6 minus root 5, right?
Yes, ma'am.
We will be getting just the first, like root 6 square minus root 5 square. In numerator, we'll be getting root 6 minus root 5. Any doubt?
No, ma'am.
Okay, I'm taking the other term, but let me clarify this one. We'll be having root 6 minus root 5. Over the denominator is only 6 minus 5. That means we will be having root 6 minus root 5 by 1, right?
Yes, ma'am.
We just did the rationalization, and while doing the rationalization, we understand our questions step and the final step. We are just having these two are equivalent fraction. Okay, so let's now take the next term, this root 8 minus root 7. That also we will be doing the rationalization. This one, root 8 plus root 7 by root 8 plus root 7. Okay, added sign over here. 3 multiplied with root 8 plus root 7 over denominator will be square root of 8 square minus square root of 7 square. That means we will be having 3 root 8 plus 3 root 7 by 8 minus 7 is 1. Okay, so we need to do the addition of this two, and you can see how easily we will be able to add them since the denominator is 1, right?
Yes, ma'am.
Okay, while doing the addition, we can say that no simplification is possible over here because, okay, square root 6 is there, square root 5 is there, then root 8 is there, then root 7 is there. So no simplification is possible. Is it crystal clear so far?
Yes, ma'am.
Today we will be discussing how to add this to irrational number, how to do the multiplication of two, irrational number. Okay. Subtraction also. Just a second. Let me take it. We need to add this too. Okay. As you can see, both are irrational. We will be adding 2 root 2 plus 5 root 3. You can write it in bracket like this. And you need to add it with the other one. Like this. Now let's open the bracket. You will be having 2 root 2 plus 5 root 3 plus root 2 minus 3 root 3. Now how you have learned to add when I will give you 5x plus 2x, how quickly you will say it will be 7x, right? Right?
Yes, ma'am. It's because the variables are same.
Yeah, because the variables are same and we are having like term. Similarly, if you are having 2x plus x, how quickly you will say it will be 3x. Similarly, this and this added together will give us 3 root 2. Are you getting it?
Yes, ma'am.
Because roots are same. If you want to if you want to know in detail that what is happening over here, then let me tell you what is happening. If you are adding 2 root 2 plus root 2, actually you are taking out common root 2, and what is remaining? 2 plus 1, and due to this reason it became 3, and this is just root 2. Root 2 into 3, that means 3 root 2. Are you getting it?
Yes, ma'am.
So this is what happening over here. Aleph, are you getting it?
Yes, ma'am.
Similarly, if I would ask you what will be the result of 5 root 3 minus 3 root 3? 5x 3x is? Yeah.
5x minus 3x is going to be 2x.
Similarly, 5 root 3 minus 3 root 3 is gonna be 2 root 3. Getting it?
Yes, ma'am.
Aleph,
Yes, ma'am.
understanding? No?
Yes, ma'am.
So we'll be getting 3 root 2 plus 2 root 3. From where this 2 root 3 came? From this black colored part. Any doubt? So
No,
this
ma'am.
is how we will be
No,
adding.
ma'am.
And this is how we will be doing the subtraction as well. Okay. Yes, Aleph, do you want to ask anything from here? Aleph,
Yes, ma'am.
do you want to ask anything?
No, ma'am.
If we will be having subtraction, suppose we are having, just a second. If this way we are having the subtraction, then just the way we have done the addition, same way we will be doing the subtraction. Okay, let's open the bracket. We'll be having 5 root 7 plus 8 root 5 minus 7 root 5 plus 6 root 7, right? Right?
Yes, ma'am.
Yes, ma'am.
Okay. So we are going to add. We are going to add this 5 root 7 and 6 root 7. 5 plus 6 is 11 root 7. Clear?
Clear.
Ma'am.
8 root 5 minus 7 root 5 will be 8 minus 7 is 1 root 5. So just root 5 we can write. So this is how we are learning how to do the addition and subtraction, just like the like term, unlike term. This way we are treating the roots. Okay. So we are discussing how to do the addition and subtraction, but don't confuse and mix it up with the multiplication and division, because multiplication and division still we will be doing the same way. If I will give you 24 root 3 multiplied with 5 root 7, that means you will be multiplying this means 24 into root 3, and this means 5 into root 7. So basically you need to multiply all of them together, and while doing the multiplication you understand you can multiply any two together. So 24 into 5 will be 120, and root 3 into root 7 you can take it as this one. 3 into 7 can come inside one root. This is the way for doing the multiplication. So our final answer will be 120 root 21. Getting it?
Yes, ma'am.
Yes.
Okay, so this is how we will be doing the multiplication. Addition and subtraction, we'll be treating it like a like term, unlike term. Okay, like term added together, like term subtracted together. Okay, and multiplication and division will be doing like this. So few more questions are there from this simplification, but majorly we have covered. Since today I have not given that much time for locating this root 2, root 3, root 5. Okay, due to that reason we have covered a lot. We have covered how to do rationalization today in exercise. Just see the last exercise, okay, or before the last, because last one is containing law of exponent. Before the last, after irrational number, whatever exercise you are having, no, there you are having one portion where the instruction is rationalize the given fraction. Please do that before the next class. Please do that. Simplification, few more simplification we are having, we will be taking it in the next class. Okay. So yes, LF and Afia, I am keeping this much. Before the next class, make sure that you are doing rationalization and locating or representing root 2, root 3, root 5, these numbers on number line. Okay, and let me know in the next class, are you having any doubt or difficulty from here on? Clear?
Yes, ma'am.
Yes, ma'am.
Okay.